All right, this video is going to introduce two procedures, two proportion procedures, specifically for proportion questions. So it's two sample procedures for proportion questions. So before we get into two proportions, we have to remind ourselves about one proportion. So this question is about a one proportion z interval. So I want you to do it, I want you to read it, and then I want us to go over it, and then we're going to branch into two proportions. So read it over and pick your answer. Okay, so I'm hoping you read the question and you saw that this was a proportion question, and I'm hoping you said pizza, proportions, we always use Z. So you know that you're doing a 95% interval, so that's the confidence level, and you need to look up the Z star for 95%, which is 1.96. I'm also hoping that you read that the sample size N was 100, and the p hat of males is 31 out of 100, which is 0.31. So now let's remind ourselves that the formula in general for any confidence interval is statistic plus or minus critical value times standard deviation or standard error of the statistic. In this case, the statistic is the p hat, which is the sample proportion. So you're going to do p hat plus or minus z star times sigma p hat. Or what is p hat? 0.31 plus or minus z star, 1.96 times sigma p hat, which is p times 1 minus p over n. And remember, if you don't have p, you use p hat. So we're going to put in 0.31, 1 minus 0.31 over n, which is 100. So if you look at the choices, remember, if you know that z star is 1.96, you know that you're down to A, C, or E. And then you know that the p hat is the 0.31, so that's going to be the same for all these, plus or minus the margin of error. So remember, if you have p, you use p. If you don't have p, you use p hat. So the p hat is 0.31, so we're not using 0.5 here. And then remember, it's p, q over n. So the n is the sample size, which is 100. So I'm hoping that you picked choice E. Hopefully you did. The name of this procedure was a one proportion z interval. And if you remember, the one proportion z interval was found in our calculator by pressing stat test and going up to letter A for apple, and that's the one proportion z interval. So now I'm going to show you what we're going to culminate in today. This question is a two proportion question. So I want you to read it over and understand why it is a two proportion question. Okay, so if you've read this question over, I'm hoping that you understand that there's actually two separate independent samples here. The two separate independent samples are 1960 and 2011. In 1960, they conducted a study with 1,018 families, and out of them, notice the keyword of indicates that it's proportions questions. So proportion, remember pizza, you're going to use Z. So in 1960, the p hat was 0.058, or 5.8% had the wife as the primary income owner. So this, the primary income earner. So this is N1, and this is sample 1, 1960, and this is p hat 1. And then in 2011, they repeated the study, and they had a second sample of 1013. We're going to call that N2, and out of those, the p hat 2 was 0.223. The percent of families that had the wife as the primary income wage earner. So as you can see, these are two independent samples, and they don't have anything to do with each other. They should not influence each other. So thus, this is actually a two proportion question, not a one proportion question. Remember, with proportions, we use Z. So if you look further, you see that it says a 99% level, so that's the confidence level. And if you look up the Z star for 99% level, we see that it is 2.576. So right away, you know that we have Z star equals 2.576. So if you remember from my little framework that I just went over with you guys on the last question, the formula is statistic plus or minus critical value times standard error of the statistic. So the statistic, instead of being one p hat, it's going to be two p hats. Specifically, that statistic, which used to be 1 p hat, plus or minus critical value times standard error of the statistic, okay? It used to be 1 p hat plus or minus z star times standard error of the 1 p hat. Now it's just going to be 2 p hats. So it's going to be p hat 1 minus p hat 2 in place of that 1 p hat, plus or minus z star is still going to be z star. And now the standard error of p hat is going to change. So if you remember in the last question, the standard error of p hat was the square root of p times 1 minus p over n, but we used p hat, so it became error. And I want to show you where to look for this. On the reference sheet here, usually for proportions, we would go here, and we would look at standard deviation is here, standard error, remember if you don't have p, use p hat was here. This is what I used here for my last question, if you recall, right here, see it? But now I'm going to do 2 p hats. So I have to figure out what I'm going to put for my formula that goes here for standard error of p hat 1 minus p hat 2. 2 p hats. So all I'm going to do is I'm going to look right under this. This says 1 proportion, and I'm going to go to where it says 2 proportions. And I'm going to use this formula right here, the standard error. So literally it looks just like one of them, but there's 2 of them. And it looks like they're adding them together. This is the one right here that I'm referring to. So I'm going to write that down on my sheet. It's the square root of p hat 1, q hat 1 over n1 plus p hat 2, q hat 2, which is 1 minus p over n2. So based on this formula now, I can plug in and solve, okay? So if you guys look at the choices, it looks like for the p hat 1 minus p hat 2, they did 0.223 minus 0.058, okay? So keep in mind, it seems like they used 2011 minus 2000 minus 1960. So we're going to actually do 1 and 2 here. So as you can see, if you have this structure here, then we're going to do the 2011 p hat, which is the 0.223 first, minus the old p hat, which was 0.058. And that's going to be p hat 2011 minus p hat 1960, plus or minus the z star that we know, which is the 2.576 from above. So we already know that we're down to choice C or E here. And then basically you just have to figure out what formula is the formula for sigma of the difference of the p hats. And I just showed you guys that it's this formula here. P1 Q1 N1, P2 Q2 N2. So the answer is choice C because this is the structure of the P1 hat, P2 hat, N1 hat, P2 Q2 N2. So it's really not too bad because it's the same kind of thing as 1 proportion. You just have to switch gears with the formula for the standard deviation or standard error for 2 p hats. Okay? So that is called a 2 proportion problem. If you have 2 independent samples, independent means they don't influence each other. Knowing what happened in the one sample will not influence the other. 2 separate groups for an experiment, as long as they're randomly assigned and they're independent. Basically, that's when we use a 2 sample problem. Usually it's the first one, the 2 independent samples, 2 independent groups, okay? 2 separate groups, and they could be different sizes, by the way, okay? So population 1 or population 2, for example, here, or treatment 1 and treatment 2. The parameter is what you're estimating. You use the statistic P1 hat or P2 hat to estimate the parameter, and they may have different sample sizes. So down here, this is showing you that you could do the independent SOCs, the shape, center, and spread for the distribution, the sampling distribution of P1 hat. And separately, you could do the independent SOCs, the sampling distribution of P2 hat. And you're basically checking those same rules of thumb that we checked for our facts for the 1 sample proportion problems. Is it approximately normal? Meaning is NP and NQ greater than or equal to 10? Remember, if you don't have P, you use P hat. NP hat greater than or equal to 10 and NQ hat greater than or equal to 10. Remember, if this is met, then the sampling distribution will be approximately normal. Remember, the center should be centered at the true center. Mu sub p hat should equal p. And in the past, for one sample, sigma p hat was the square root of p times 1 minus p over n. And if we didn't have p, we used p hat. And remember, we use that only if the rule 10n was less than the population of interest, which is what this is saying here. So basically, this is showing you that we could do these two separate rules of thumb for the two independent distributions, checking basically all of our assumptions or conditions twice, which really takes some time. Not going to lie, it takes some time. So what if we combine the two p hats and we did the difference of the p hats? Then what we would have is the sampling distribution of the difference of the p hats. Okay? So notice again, it's going to still be approximately normal for the shape, as long as the conditions are met, and 1p1 hat greater than or equal to 10 and 2p2 hat greater than or equal to 10. If that's met, then the shape of the difference will also be approximately normal, which you see it is. The center should be centered at the true center, which is mu of p1 hat minus p2 hat. It should be centered at the true p1 minus p2, the true parameter. And then the spread is that formula from the reference sheet. Okay? So I'm not going to write it again. I'm just going to show you on the next slide here that it sums all this up that I just said. It sums up the shape is approximately normal as long as those are met. It says the center is centered at the true parameters, p1 minus p2, and it says that the standard deviation is this formula here. Now this formula is on the formula sheet. I showed you where it is located. And I think this formula should be on the formula sheet too. Let me double check right now, but it should be right next to the standard deviation. So if we go back to our reference sheet, do you guys see that right here? We just went over here, this one, the standard error formula. This is the standard deviation formula, standard error formula for two proportions, and here's the mean. The mean of the p1 hat minus p2 hat, the center, should be centered at the difference of the true parameters, and this is the spread. So basically, everything's on the reference sheet. You just have to know where to look, and I think that's a hard thing for kids is they sometimes don't know where to look. And just remember, you always have to check that your conditions are met before you proceed with the standard deviation formula, okay? So guess what? We can do the same thing that we did in our do now, basically just doing a confidence interval or a panic for the proportions, okay? So we're going to do that now. Patients with lower back pain are often given non-steroidal anti-inflammatory drugs to help with their aid. Researchers want to know if Valium along with naproxen would affect pain relief. To find out, they recruited 112 patients and they randomly assigned them into two groups. So this is an experiment. And it is an experiment because treatments are imposed. There are two treatment groups and the two treatments are imposed. And the two treatments are the naproxen group and the Valium group. And because treatments are imposed, it's an experiment, and thus we can conclude causation. So naproxen and Valium, or naproxen and placebo, sorry. Naproxen and Valium is the one, and then just naproxen combined with a placebo is the other treatment. So that would, I guess, be the control group. After 1 week, so now we have some statistics, okay? 39 out of 57 subjects who took naproxen and Valium reported reduction. So we have our first p hat. So I'm going to call this p hat 1. That's going to be naproxen and Valium. And that's going to be 39 out of 57. And that's going to be p hat 1. They reported reduced pain. Okay, so let's do that. We get 0.684. Now we have p hat 2. Whereas 43 out of 55, that's going to be the naproxen and placebo group, reported reduction of pain, 43 out of 55. Okay, so the first thing to note, 0.7818, it's been 782. Okay, the first thing to note is that you really should label all the key information, okay? So I recommend that you state the populations, like state group 1 and group 2. So say group 1 is going to be naproxen and Valium treatment. So that way people know when you use the subscript 1, that's referring to the naproxen and Valium. And group 2 is going to be naproxen placebo. Okay, we have P1 hat, we have P2 hat. Great. So we should also note that we're eventually going to do panic on this, and we're going to have to do the populations of interest, parameters of interest, assumptions, etc., etc. Part B says construct and interpret a 99% confidence interval, so that's the confidence level C, for the difference in the proportions. So proportions use Z. You guys know we did the Z star from before. It was 2.576. We're going to use the same one here. For those who report reduced lower back pain after taking naproxen and Valium versus taking naproxen and placebo. So every time you do a question, you have to ask yourself, self, is this means or proportions? And you know it's proportions. Z or T? You know it's Z. One sample or two? Two samples, two proportions, because it's two separate groups. Hopefully they're independent of each other. And then is it an interval or a test? It says it's an interval. So if it's an interval, just know that starts with I, so you're going to do panic because panic has an I in it, not phantoms. Okay? So let's just jump to the interval step, which is the I step. Okay? So remember, we went over it before. It would be confidence interval equals statistic plus or minus critical value times standard error of the statistic. So it's going to be P hat plus or minus Z star times sigma P hat, right? But instead, it's going to be P hat 1 minus P hat 2 for the statistic plus or minus Z star times that formula from the reference sheet, the square root of this one right here, P1, Q1, N1, P2, Q2, N2. But we're going to use hats. P1, Q1, N1 plus P2 hat, Q2 hat over N2. So every time you guys see a 1, you're going to go to group 1, and every time you see a 2, you're going to go to group 2 above. So the P hat 1, if you go back up, we divided it out, and we got 39 out of 57, or 0.684. So we're going to do 0.684 for the naproxen and Valium group, minus the other group was the naproxen placebo. We got 0.782. So that's going to be your P hat 1 minus P hat 2. That's your statistic. Plus or minus critical value, 2.576. That's your Z star. Times square root of P1 hat, Q1 hat, N1, P1, 2, 1, N2. I said it. I don't know what I just said. 0.684. 1 minus 0.684 over N1. N1 was 57 and then 55, right? 57, 55. And then this one was 0.782. 1 minus 0.782 over 55. So now guess what, guys? You don't actually have to do this out by hand. That would be like really annoying. But now what you can do is go to your calculator, okay? So on your calculator, I'm going to skip ahead to my little calculator screen. You are going to go to, oh, don't tell me I don't have it here. Bummer. On the calculator, you're going to go to stat, go over to test, and find the 2 prop Z interval. So remember, I told you for the do now it was a 1 prop Z interval. Now it's a 2 prop Z interval, letter B. It's right underneath A, right? So choose that. Now you're going to put in X1, N1, X2, N2, okay? Not so bad. You just have to know where to look. So the X1 was 39, and the N1 was 57. Remember, you don't divide them. You just put them in numerator separate from the denominator. Then the X2 was 43, and then 55. The 99% level, and calculator draw. So we get negative 0.3114 to 0.162. Okay, I'm going to come back down here, and maybe I'll just screenshot this right here. Okay, so notice that it could be negative difference, or it could be positive difference, or it could be 0 difference, right? So it seems like we're not really that confident what the difference is. So the interval is negative 0.3114, comma 0.11623. So now we have to make our conclusion sentence, okay? So we say, I am 99% confident the true what? The true parameter, right? So in this case, it's the true difference of the proportions of patients who report reduction of back pain between, and we want to put it in the order that we had subtracted it. So we did the between the naproxen and Valium combo and the naproxen placebo combo is between, and then you want to put your blank and blank. So between negative 0.3114 and positive 0.1162. Okay, so I know it's a lot, but it's really that same shell for panic that we did before. Blank percent confident that the true blank is between blank and blank. Okay, not so bad. There it is, okay? So now, if you look ahead, I'm going to kind of scroll ahead here. How can I connect this to a significance test? Okay, so test starts with T. That's going to involve phantoms test. Okay, so it turns out we're going to want to do the same kind of thing that we did for the one sample, one proportion Z test. We're going to want to do it for a two proportion Z test. Okay, so I want to connect your HO and your HA to this. So this says, based on the confidence interval that we just got before, what conclusion can be made about whether taking Valium along with naproxen affects pain relief? So basically, we can't really conclude a lot because remember, this interval spanned from negative to positive. So it could be that naproxen and Valium does better than naproxen alone, or it could be that naproxen alone does better than Valium, or it could mean that there's no difference, right? So how can I connect this to hypotheses? Well, the hypothesis, the HO, would have been P1 equals P2, meaning, if you put them to one side, P1 minus P2 equals 0, meaning there's no difference between the treatment combination. Okay, so basically that's saying, oh, there's no difference. And then the alternative would be maybe you thought that P1 was better than P2. Maybe you thought that the combination of naproxen Valium, because remember 1 is naproxen Valium, and 2 is just naproxen alone with placebo. So maybe they were predicting that naproxen Valium was going to be better. So then that would be a greater than sign for the alternative. Naproxen Valium is a better pain reducer than naproxen alone. So how can we connect it now to our interval? So our interval, if you recall, was negative to positive, negative 0.3114 to positive 0.1162. Okay, so that is a 99% level, right? So look at our null. Our null is that there's no difference, that there's zero difference. Is 0 contained in the interval? And the answer is yes. Sometimes it's positive, sometimes it's negative, it could be 0. It's plausible that there's no difference, right? So in that case, if it's in the interval, you fail to reject the null. And if you fail to reject the null, we can conclude in favor of HA, which says that naproxen is indeed better than Valium. So basically, we don't have conclusive evidence that indeed the Valium and naproxen is better than naproxen alone. So I'd say we don't have statistically significant evidence that the one is better than the other. Okay, so we can't reject the null. All right, so that is the tie between the interval and the test. Now, how do we actually do the test though? Remember, we do the whole phantoms, right? I'm going to kind of skip ahead here because we did just talk about population, parameter, hypothesis, conditions. I want to jump ahead to something new, the test statistic. So you guys know for proportions we use z. So this is going to be a z-score, okay? For a one proportion z-score, our formula was statistic p hat minus parameter mu p hat, which equaled p, by the way, p hat minus p, over standard deviation of p hat, which was the square root of p times 1 minus p over n. Sorry about the bell. Okay, so now for a two proportion test, you're going to kind of do the same structure, statistic, right? So the statistic, instead of being one of these p hats, which is right here, it's just going to be two of them. So it's going to be p hat 1 minus p hat 2. Instead of one p hat, it's going to be p hat 1 minus p hat 2. That's the statistic, minus the parameter. The parameter was just p, right? So it's going to be p1 minus p2. And then the standard deviation, or the standard error of the statistic for one proportion, was this, okay? For two proportions, when we look at our sheet, we have to go down to, instead of using this one, we're going to go to this special case. So do you see it says when p1 minus equals p2 is assumed to be true? That's only for hypothesis tests. Then we do this special case formula, which is written right here. This is going to be called a pooled p hat. So let's write it down and then I will explain. Okay? The p hat c is actually the pooled p hat. All right, so let's write that down. It's the square root of this p hat c, which is p hat pooled, 1 minus p hat pooled, 1 over n1 plus 1 over n2. This is right off the formula sheet, and it's the one that says special case. Okay, right off the formula sheet. So what is p hat pooled? What does that really mean? So basically, we are assuming that p1 equals p2. Okay, in the null. That is what our null hypothesis says, that there's no difference between the two. So this common value, because we're assuming they're equal to each other, what we can do is we can combine the two pieces of data from the two samples into one. And this seems like it's not mathematically sound because we've never really just added across numerators and denominators when we're combining fractions in the past. But for this is how we get the p hat pooled. What we do is we add across the numerator and we add across the denominator to get the pooled p hat, okay? And I'm going to show you what I mean by that in a second here. But basically, the formula, when it's a pooled p hat from above, is going to be, instead of, this is not pooled. This formula here is the not special case one, not special case. When we do the pooled p hat, we're going to use this formula here that I just wrote for you guys on the bottom, okay? So I am going to do that pooled p hat now for the question about the naproxen and Valium. So I'm going to go back to here, and I'm going to go back to my data. All right, and do you see that we had for our numerators, we had 39 and we had 43, okay? If I wanted to do the pooled p hat, what I would do is I would add 39 plus 43 across the numerator. And that's going to be called p hat pool, which for some reason they use the letter C here. It's weird. I guess they didn't want to write p hat p. And then the denominators you're going to add across as well. So you're going to add 57 plus 55. 57 plus 55. That's going to be my denominator. So to get our pooled p hat now, what we do is we would go to our calculator and we would just put in 39 plus 43 over 57 plus 55. And you would hit enter and you get 41 over 56 when it's reduced, I presume. Okay, or if you want, you could divide that and see what you get, 0.732. Okay, so now we have our pooled p hat. So let's say I wanted to do phantoms on this data. We already set up the two populations. We already did our hypotheses. We got 41 over 56 for our pooled p hat, all right? I'm going to just do it under here. So when I do my z-score for my test statistic, I did p hat 1 minus p hat 2. That's our statistic. Minus parameter p1 minus p2 over the formula for p hat pooled, 1 minus p hat pooled. Again, this is off the reference table. 1 over n1 plus 1 over n2. Okay? I'm going to write the data here for you on the side. Okay, so on the side here, I wrote down the information that we need to know. Population 1 was the naproxen and Valium group, and that was the p hat 1, 39 out of 57, or 0.684. So that's going to go in first for p hat 1, 0.684, minus p hat 2. P hat 2 was 0.782, and that was the placebo group. Okay, minus. Now, P1 minus P2, what are we going to put here? We didn't know the true proportion of people who take naproxen or Valium at all. But you know what we do know? Our null hypothesis was that P1 equaled P2, or that there was no difference between the two. So you're assuming that there's no difference between the two. So in here, where it says P1 minus P2, you know what we put? 0. Because you're assuming that the difference between the two is 0 in your null. And remember, you always put what you're assuming in your null, okay, which is there's no difference. Over. Now we're going to do this piece here. This piece I'm going to highlight in aqua. It's going to be your pooled p hat formula from your reference sheet. Okay, so it's the square root of p hat pooled, which down here I put on the right was 0.732, or 41 out of 56. So 0.732, 1 minus 0.732, 1 over n1 plus 1 over n2. n1 was 57, and n2 was 55. Okay, so this looks kind of scary, but we got everything done. And now, guess what? We can go right to our calculator for help. So we're going to go to stat. We're going to go over to tests. And we're going to go down to the 2 prop z test, which is actually number 6 here. It's under the 1 prop z test, which was number 5. Choose it. And then you're going to put in your key info. We already have it in here because we already did the confidence interval on this. 39, 57, 43, 55. And then the alternative would be depending on what we presume. So I think they were predicting that naproxen and Valium was going to do better than just naproxen alone. So I'm going to pick a greater than sign. And then you could choose calculate or draw. I got a z-score of negative 1.166. That is called your test statistic. Remember, it's a z-score or a t-score. So it is your z-score in this case. And then the p-value, remember the O step of Phantom is obtain the p-value, right? Obtain p-value is right under it. It is the 0.878. Okay, so is 0.878 less than 0.05? No. So do I reject the null? No. So for the M step, make a decision. You're going to say, because my p-value of blah is not less than 0.05, I fail to reject HO. Thus, I can't conclude whatever. So this p-value is 0.878. So my p-value of 0.878 is not less than alpha equals 0.05. I failed to reject the null. So the last statement is the sentence in context. So you say, thus, I don't have statistically significant evidence that whatever HA says, which is the true proportion of patients who report pain relief this is long, sorry. In those who take the naproxen Valium combo is greater than naproxen alone. All right, this is quite long, I know, and I know it's a lot, but actually it's really the same stuff we've been doing with the one proportion. It's just now with two proportions. But what I want to remind you is that when we get to the A step, which is the substance conditions, you basically have to check everything twice, and that makes it longer and really more challenging, okay? So the last thing that I'm going to leave you with is, well, first of all, I just want to say this conclusion is what we already predicted, because when we did our confidence interval, we said that we failed to reject the null because the 0 was not in the interval. So now we actually did the p-value, and we agreed with that decision. So the last thing that I'm going to leave you with is this question. I am not going to do it with you. I want you to read it. I want you to write down all the key information that you can about it. I want you to identify group 1, whoever they are, POP1. I think these are two populations here, POP1 and POP2. Parameter 1, parameter 2. That's going to be the P step. Okay, so basically that's the P step. Then I want you to do HO and HA, okay? And then you can try to start checking your conditions. When you check your conditions or assumptions, you're going to do everything twice. So it is annoying, and you have to actually add another conditions. Are the two samples independent of each other? Okay, then you're going to do 10N1 less than POP1, 10N2 less than POP2. Are they independent SRSs? Let's throw that in one. Are they separate simple random samples? Are you going to do 10N1 and 10N2? And lastly, NP1 hat greater than or equal to 10, and Q1 hat greater than or equal to 10. If you have P, you use P, by the way. And 2P2 hat greater than or equal to 10. If you don't have P, use P hat here. So that is a lot, okay? And then we'll come back together and we'll actually do the test together. All right, thank you for your attention.